They are right one after another. Wow, and they are the same size. Hello world, and welcome back to another episode of my Squirrel side quest. In the previous episode, I managed to get a decent progress. I got an adder-off primitive, a fakeObj primitive by spraying strings, and then I decided to change the approach by getting another fakeObj primitive, but this time by spraying blob objects. However, it was very challenging to shape the heap to make the chunks land right in the order that I wanted. My strategy to get a fakeObj was: Step 1. Allocate a class object. Step 2. Allocate a blob object that will be located after the class object in memory. Step 3. Populate the blob buffer content with a fake SQ object pointer, which is essentially how variables are represented in memory. Step 4. Use the type confusion bug to trigger an out-of-bound access, and as a result, get yourself a fake object of which you control all the bytes in it. From there, it should be easier to achieve more powerful primitives like arbitrary read-write, mainly because we can fake any type of object in the Squirrel VM. The blog author suggested a pretty common technique in language interpreter exploitation, and that technique was faking an array object that points to null and has a lot of entries. After many attempts, I got it right. But the moment I changed one line in the script and rerun it, everything breaks and the order of chunks is changed. Okay, so today we continue with the exploit debugging to see why our payload is not written here. So let's see. fakeObj. Okay, if you do it itself. Default values. 46. 45. So vowels begin here. And buff. It's going to be fakeObj. Buff. Print obj. No. Print obj. Now We can see buff. And we can see vowels. And if we access, if we calculate the distance, wait, what? Oh, no, I'm sorry. It's supposed to be. Right. 45. That's why 46. 45. Oh. Okay, so we should do that. Mm-hmm. Yeah. Now it's in the beginning. And now if we measure the distance between the buffer and where default values begin, yeah, and .45 string, perfect, very nice. Okay, now we have a type of string. And what happens if we do that? It's supposed to be the same effect. Yes, perfect. Okay, then Yurik's dead beef. Mm-hmm. Well, that's weird. Oh, I think I know why. This is because the dead beef is here. So we need to like do this. Oh, now this is the type, padding, right there. 32-bit, but other 32-bit. Okay, now let's see. Files. Yeah, that looks good. And if we print it, perfect. Looks good. It looks very good. I like that. Okay, So now we can print fakeObj. Is there like type of type? Yeah, they have type of. Type of fakeObj. Our fakeObj is should crash, right? Should print string. Because that's 0. That's weird. strlen. Let's see it here. Type of fakeObj. Yeah, I think I know. I think I know why. This is because lower 3 to 8. Okay. So if we comment that, we should see a sec fault with dead beef. Okay, that's fail. What? Yeah. Oh, maybe select the attributes. Okay, let's attributes What if we do this? That looks better. Now, no. Okay. Still no. RLM. This is a null pointer. Type of. We'll get meta method. Delegate get meta methods. That's weird. What type of is calling add? You know what? Never mind. Maybe we can. That's still 90. Why? That is weird. Six, 45. Okay, you know what? Just to make sure, let's write it twice. Continue. That's 45. And that's 46. And now we'll remove that. No, come on. How? Oh. That's 0x20. 0x20. Should we, like... I don't know. 45. 37. Still think it should be 46, but... yeah. Okay, one more. 'Class member. Yeah, that's 0x20. So every time. Really? Okay, the heap messed up again. Okay, what if we do this? Will that change the layout? Print object. Yeah, that's not good. Okay, it's time to check the sources. Try to avoid it, but you can't avoid that shit. Okay, that's just malloc and realloc and free. This is just wrappers of libc ptmalloc. Okay. Class. So every time we create a new class, let's get where we create it. Default values. Where you initialize them. This is get constructor. There is no set. Let me check again the references. You're taking that reference and It's right here. Return new class. That's odd. Clone. Let's see. No, this is related to the garbage collection. Okay, who calls create? Class op. And then you have attributes. Stack vals. Stack base class. And then you're doing target, meta methods, not now. Attributes. Okay. And nobody talks about default values. This is literally the opcode to create a class. And there's no mention. Too many syntax. This. So you initialize meta methods, but you never initialize default values. That's very weird. Very weird. Oh, what is this? It's literally here. Okay. And it's also here. So when you create a class that has a base class, you would copy the default values of the base class. And when you finalize the class, you will take it looks like a copy. Default values, size, and then it's just Okay, what else? New slot. new slot. We'll take the default value. Take the default values. And append. Right. So what we can do to make this more predictable is to take, oh, what? No, is to take that and make it bigger. Right now it's like 1 and allocated 4. The size of it is 0x90. So we're gonna make it bigger by and more 1. And then over 2. 3, 4. And now the size becomes plus 20. No, we need to fill 4 slots. So it's 1, 2, 3, 4. And now it will grow. Now it will grow and become it will grow and become realloc size times 2. So eight. It's going to be 8. Allocated becomes 0x8. So if we run this again, we should see that it's changed. That's weird. Oh, I need to do it by 5. Sorry. Yeah. Now the size is doubled, so now the size is doubled. Maybe it will put it somewhere else. You know what? Maybe we should. Let's make it even bigger. That's 5 and 6, 7, 8. Now it will be like super big. And I want to make it bigger because the bigger the chunk, the less common the size of it. And the less common the size of it, meaning that that the heap will be more, I don't want to say more predictable, but like less inconsistent. So now it's really big. Okay, that's 210. Now, when we look at our buffer, 210. What do you mean? Oh, I'm sorry. Now we have vals, and now we have buff. That's still how? How is that even possible? Okay, what is the size of? Maybe I got this wrong. Heap chunk. Yeah, 210. And that's heap chunk. 210. So they fall into the same category, but for some reason, you know what? Let's make them 420. That's like 9, 10. I'm so sorry for this. Right, so that was 0 20, 0 20, 0 20. 33. Okay. Yeah, there's no way I'm writing all that manually. Okay, now that is supposed to be no, I'm sorry. Shall clear. Chunk. Oh, that's times 2. Like, that's very big. You know what? Okay. Let's continue with that size. No, I don't want to. Almost there. Almost there. I can't believe it. Okay. Now let's make it. now it's gonna be yeah, and then heap chunk. That's weird. Okay, 1C, so 1D, 1E, 1F, 20, 21. Oh, I see. We can't hit 420 because it will double it, and then it will become like 820, like we've seen earlier. Okay, so we'll stay with 820. Let me just make sure. Yeah, like 800. I'm sorry, because 0x10 bytes for libc are reserved for libc. So okay, we'll stay with the 800. And here we will. The size of buff will be 0x800 and 10. All right. Okay. So now that looks very good. Wow, that looks very good. They are right one after another. Wow, that's, and they are the same size. Damn, nice. Very nice. Okay, so 0x10. This is gonna be 65-ish, I think. What else? 60. Let's see, 64. Nah, almost. 63. No, 65. Okay. So that's 65. And we need to how much? Like 0x8, I think. Oh my god. That was oh my god. Okay, now we're going to see 64. No, 65. No, shit, I'm sorry. Yeah. Okay. So I think it's this second dead beef. Like we should do this and then 65. It's the 64th index. So $63. 66. No, that's weird. Oh, I see. Okay. I see. So what was wrong with my calculation? It should be plus 8. And then, oh, that's stupid for everyone who's watching this. Probably laughing right now. $64. No, come on. No, I don't want to. That's 1. And then 811. And then 19. I think it's just... Yeah, it's here. We should do this. Shell clear. Now we say 64. Does 64 shame the same address as buff? No. Buff is 0x10 difference. So we should do this and then go one index above, and instead of 64 we will put, there's like a misalignment. Now we will see 65 and to perfectly match our 65, right? Yeah. What? Oh, okay, I'm sorry. It's 65. Very cool. And if we go to 64, it won't be... Yeah, okay. And 66, just 90. Looks good. Looks good. Okay, so now we can remove this and try that. Or that, I don't know. This one should crash, I think. Or print string. Yeah, it's crashing. Okay, how about that? This one should crash too and not print 1990. Why it prints 1990?
Oh my gosh, there he is.
What? fakeObj. How? $66. Okay. fakeObj. Pounds. Okay, I think I know why. What is the offset? Like, what is the distance between this and that? No. No. No way. No, come on. What is this bullshit? You don't even have. That's stupid. fxcking. Print. Maybe it should be 65. Although I think it should be 66, but okay. 65. 67. That's weird. I don't know what to say. Honestly, don't know what to say. The class is already having a huge size, and like, I don't know. The class already have this size, and the buffer was allocated after. It's allocated after the class is allocated. Yeah, and then we're accessing out of bounds, getting the same address. And we start to manipulate that buffer to fake a string object. And then that's very weird. Should we make like more classes like that? What will happen? Okay. Vowels. And the distance is 0x810. 80. Hmm. Like the address of buffer. Yeah, that's not good.
Oh shit. Here we go again.
It's before. It's before. Maybe if we just allocate more classes. Keep chunks. Okay. And hit bins. Yeah, just those ones. Okay, I think it's just we just need to allocate more. That's the pointer of vowels, and that's the pointer of buff. Yeah, that's still before. Okay. You know what? Can you like specify negative number? No, I can't. Um, maybe. Maybe. I can move it like that. No, that's not good. Maybe. Can do something like that. Okay. That looks less far. Is this the same? 710? 710. Yeah, it's the same. Like, okay, from 0 to 26. From 0 to 26. Let's see if that makes any difference. Nope, still the same. Um, um, what if we create an instance of that class? Classes. Instance. Yeah, that's how you create an instance. Yeah, cool. Now, okay. Okay. We'll occupy. Well, we'll fill those. Okay. And now if you look at vals like 65, perfect. Cool. So I just hope that now everything will run better. No, that's still not. Mm. Hmm. Okay. That's 66, 64. XD. Okay, let's try one more. $67, $68, $65. I don't know. Okay, we'll do 67. $68. I don't know what. I don't know. I think maybe it's just okay, let's try that. Now we're stepping into obj is a very big number. Yes, it's this. And then obj will turn into this fake object and be returned into fakeObj. So let's see it happening live. Okay, jump. Right. Now you are. Okay, that's better view. Right, let's get key and val. Now this is not a null, so and then we compare ex and yes, it compares. So we'll jump here. Actually, integer. That's weird. He's supposed to have out of bound here. Okay, compare EAX. RSI. That's weird. Okay, what is obj? Integer. I don't get it. And now we're back to get. Mm-hmm. Compare. RCX. Yeah, that's the class members and the type. And that's, I don't know, like, mm-hmm. Yeah, that's 8, 10. So it begins here. I think I know what's the problem. We are copying it. It's copying it. Like the get operation. It's not putting a reference. It's creating a new object. Copies the content. So what we should do is this? I think. Let's see. So the first time we're doing rawget, and then the second time we're printing obj. I don't know. I don't know. Let's see if I don't know. Oh, finally. Oh, finally. Yeah, now we are trying to read from obj, and obj is dead beef. Yeah. Okay. Okay. So, yeah, now we have a better heap shape and an ability to craft an arbitrary object. Let's see what happens if we add another function. Other off func. Yeah, func. And that's not related to the function. I'm just curious to see if that will fuck up the shape of the heap or everything will stay intact. Yeah, it looks good now. What you can do, I don't know. Look, print, print, right? And we can say 2, 3, 4. And print other 32. I hope it supports those operations. Yeah, it's not. Between bitwise op, between null and integer. Right, because you need to return it. of course. Okay, and now do continue and print obj. Obj has a type of, I don't know what's that, but a rawget, fakeObj. Okay, what about vals? The 60. Or something weird happened, but I don't know. One, two, three, four. Oh, what? 1, 2, 3, 4. Yeah. So you take the lower bytes, and then you write the upper bytes. What's wrong with it? Type string. That's just padding. Okay, you know, let's continue. It's probably segfault, but what? That's weird. fakeObj. Okay, what's going to happen now? Integer. Now let's see it. Okay, one more. It's crashing because of the type of, I think. No, I think it's just reading from this number. Let's make another breakpoint after the print. Right. So that's the object that holds print. And we want to 4310. I can't see any of it. That's fucking weird, but okay. Balance 65. 64. 65. Yeah, I have a feeling that. Oh, no. No, come on. No. Okay, I need a break. I need a break. I can't take that shit anymore. Hello, everyone, and welcome back. This is day, I don't know, like day 3 or day 4 of me trying to do some heap shaping or heap grooming, whatever you like to call it. Last time I actually it did work, but for a short period of time. And we need to think what to do. Maybe if we observe all the mallocs that are happening during the execution of the script, it will give us an idea about what's going on in between, because the problem is like in between. It's between here, where we are creating the class object, and when we are calling this, which is allocating the buffer that we want this buffer to be placed right after the members of this class, the default values. Yeah. Yeah, obviously we don't want to break all of the condition. What breakpoint is this? Condition 5 RDI is bigger than 0x800. Continue. Okay, here he allocates like 4 by 4 pages, and that's A00. A00 again. And it comes from create. No, it's the lexer. We're still in the lexer phase. So we're not interested in this. Yes, it's still compiling the script into bytecode. So we'll skip that. Statement, class statement, alloc nodes. Let me see that. He's still compiling. compile. Okay, that looks interesting. No, it's still compile. Right, now we are executing. Yeah, call and then execute. Now we're executing the bytecode. So let's see one malloc of this size, which is A00, and then 1400, 2800, 5000. Okay, it's like doubling itself. Okay. Now it's 1400, and then it's gonna be probably like 1800. No, 28, yeah. Okay, so it happens during raw set. Oh, it's happening during raw set because of that loop. So if we do print lol, okay. And then we do run. Still compiling. Okay. 1400, and then it's going to be 2800, 2800, and if we scroll up, we will see all those lols in between the mallocs. So there are a lot of, not just allocation, I think it's doing a lot of reallocations, and that causes a lot of holes in the heap, and it's not good for us. Let me just make sure that this is the reason our heap shape is fucked up. SQ malloc and size. SQ malloc. No, it's not reallocating. I'm just doing malloc again. Okay. That's weird. Maybe, I don't know. Members, new slot. Key not found. Okay. Rehash. And rehash is old size and elements using more than alloc nodes. Yeah, look at that. Times 2. Yeah. And it's in line 54, which exactly what we're looking at right now. So, yeah. So it reallocates it with a bigger size because the hash table is filled up. And after it reallocates it, it frees the old one. Okay. So those calls to free are the problem. So maybe instead of we are allocating it here after this loop. So we should do this. Let's see. Disable file and then run. Oh, right. Okay. That's awkward. Run. Oh, that's a lot of prints. How do you... Okay. Let's makes it like dramatically slower. Okay, rawget, and then rawget buff. fakeObj. Okay. No, make self. No. Files. And the distance between this buffer and the values buffer is 810. Perfect. Perfect. Now, oh my god, I think we solved it. I hope we solved it. Now buffer is allocated right after that class. And if you want to like access 65, just like we did previously. And 65. Okay, what's that? Oh, it's the address of print. Did we print it? No. Okay, let's print it. Address of print is, and then print. Okay. Continue. 65. Not good. Okay. Address of print is like 970. No. Not again. I feel stupid. Okay. Gripped SDR, and then that's 9970. So 9970. Nice. Now we can fake the type, which is string. And we can fake the pointer, which is this. And we can fake the attributes, which is, this is the attributes. Looks good. Looks good. but I have a feeling that it's still not reliable. Like, what happens when you run it? The index does not exist. At line 109. Okay. How about now? No. Yeah, I think I know why. Okay. No, I'm sorry. I need to do this. Continue. Yeah, that's not. It's not good. Maybe we should move it. Come on. Maybe we should move it like down. Continue. Buff. Buff and what else? Of course. What's okay, that's after. That's after. I don't like that offset, but at least that's after. Okay. 489. Yeah. I'm just keeping this as a backup. Okay. Yeah. Now it's better. Let's see what happens. The index does not exist. No. Why is that? Oh, because we need to 489. That's what we need to do. Oh, that's shit. No. String. Holy shit. We have a string. What? Okay, now let's see the length of that string. How do you see the length of a string? String. the string library. Len. Come on. Oh, no, I feel stupid. Ends with escape, format, printf, strip, split, strip. Come on, you have to have a length. Oh my god. Print string print len. Okay. Print len abc. Why? Because probably len is probably for arrays or something. Okay. String.learn. Print string.learn. Now I feel stupid. Print cool. Our fakeObj is that, and it's probably like either it's going to be a pointer or like something that is part of the, yeah. It's like a pointer that is inside the so-called string object, but it's actually part of a function object. Okay. God bless type confusions. Wow, that was... Whew, that was fucking... Okay. Okay, let me see that. So we're gonna run this again. And this time, fxcking. Break here. And continue. And then ouch. Okay, that's sus. But I will ignore this for now. Grabbed str 970. 970. Okay, so I didn't copy the attributes. I just copied the object. Okay. So we're going to do print obj. Well, you're joking? Oh, it's print obj unval and then p string. Yeah, and the len is a very big length, because we tricked it. It's not an actual string. This is a p function. No, like p closure, I think. Native closure. It's a p native closure. Yeah. Mm-hmm. This is the closure that points to print. And we are confusing it with our own type, that is string. And it thinks that the len is C to B0, but actually C to B0 is shared state. So that is a pretty convenient way to first of all, to leak the address of the shared state, because this is a very important structure, but also to get an out of bound read. Now we can take this string and because the size of that string, the length of the string is very long, we can read everything beyond that chunk. So if this is the object that we see here, this is where it ends, like 2. This will be the contents of the string with a very long length. So we can just read everything beyond. Everything beyond that string. I really hope that their strings are mutable, because if they are immutable, then we're going to have a problem. You will need to fake another object, not a string, something else. I don't know, like an array or something, or a blob object. But yeah, anyway, I'm really happy that I managed to fix the heap shaping. So to sum up, to correctly heap shape the Squirrel VM memory, the first thing we need to do is to make the class to be very big. So it will, so the allocator will, I don't know how to say it, the allocator will correlate it with chunks that have big sizes. And because the size is big, it's an uncommon size. So we have less chances that some other chunk will mess up with the order of allocations. So that was one of the things. And then we had another issue, that even though we made this a very big size, still some other chunks that also have big size were allocated, and it destroyed our whole heap grooming. So after some debugging, we could see that it's because of that part. Because we are setting a lot of new, I don't know, attributes or properties to this class. It goes into a, I don't know, how was that called? Like rehash. Where is it? Rehash. And the size of members of like the SQ class members is growing. So it allocates it and frees the previous table, the previous hash table. And it's not good for us because this loop is running a lot of times. So what happens is that the engine just calling a lot of time free with a lot of different sizes. And it's creating a lot of mess in the heap. So to resolve that, I just took the function and the place where we call it and put it before everything starts to be messy. So yeah. And that's it. And that's how we managed to create a fakeObj primitive, which is super cool. I'm really happy with that. Type string. I can stare at this for hours. P-string. No, P-string. Like that. Yeah. With a very large length. Cool.
Who are you?
I've been asking the same question. Am I the son of a panda? The son of a goose? A student? A teacher? Turns out, I'm all of them. I am the dragon.